had some questions on using this little fact. It's technically a theorem. So I want to make a step-by-step example video just to kind of break this down. So I'm going to be doing these two examples here, and I'm just going to really kind of take my time with this and explain everything. And the whole point of this is that I need to use this theorem. And there's kind of the two different forms of this. Now, this is not a simple fact, actually. If you think about it, if you plug 0 in, you'll get 0 over 0. Just to be totally clear, 0 over 0 by itself does not make 1. This is called the indeterminate form. If you do this, it makes me look like this, and then I'm sad. So we don't want to make me sad. So this is actually kind of a surprising result, that this works out to be 1, and it's not an easy reason why. And I made a really cool video about why this works. So if you don't know why this works, I highly recommend checking out my proof video. It's not too long, and it will really kind of explain to you. It's actually a really beautiful result, I think. Like, this is, if you want to try to really expand your mind and get a deeper appreciation of math, I'd recommend watching it. So, okay, enough of me going on about how much I love math. So this is like the most basic example you can get of this type of problem. So notice if I plug in 0, I will get that 0 over 0. Okay, so the second you get that needs to set off your spider sense that you've got to do something different. Now, the next thing with this is that you cannot, there's nothing you can do to this. You can't reduce this any farther. It's not a thing. I had this question come up. You can't do this. This does not equal this. That's not how sign functions work. So once you have something kind of in the sign function like this, it has to basically stay in like this unless you use a trig property or identity. That's the only way you're going to do anything with that. So this is really what it is. So the problem is this does not look like my theorem, right? And why? It's because there's that 7. I've got that darn 7 right here. But here's the deal. I can use this as long as really these two things are the same. So it doesn't matter what's there. As long as this and this look the same, I'm good to go. So to be really, really clear with this, if I had, give me any number you want, k. If I had sine of kx over kx, so this limit, if I took this limit as x approaches 0, this would also equal 1. So this is like a manipulation I can do that will allow me to use kind of this overall theorem. So basically all this is getting, as long as these two things are the same, you're golden. All right, so going back to this, so this isn't what I want. The problem is there's a 7 here, which would mean that I'd like a 7 here. I don't have that, but I can manipulate this. And I can manipulate this by multiplying by 7 over 7, like this. Now, if I do that, let's be a little clever in how we write this. So I'm going to rewrite this, put this 7 out in front, and then I've got over this 7x. Okay, so really, now I've got these two things are equal. So I'm just about there. So the one thing that I want to do, though, is I want to make it really clear where I'm using this theorem. So basically, this 7 is a little extra. Okay, so what I'm going to do is I'm actually going to break this up into 2 parts. And I'm going to be like just really drawing out the detail here. So I'm actually going to break this up as 7 times sine of 7x over 7x. So now I've got these 2 pieces. Now if I really want to go crazy with this, you don't usually have to do this, but I just want to be super, super clear. I can go one step farther and break this up into these 2 separate limits. Like this. Okay. And so now, in looking at this, the limit as x approaches 0 of just 7, that's just going to be this constant, right? So this is just going to go to 7. And now this, oops, and I lost the x, my bad. It should say 7x. Okay, and this now is literally just me taking this theorem. I've got the same things here, so the whole thing equals 1. So this guy here is going to go to 1. So the way that this turns out, this comes out to 7 times 1, so this will equal 7. So that's the final answer. Okay, so now let's just take a look at something just slightly more complicated. So at first looking at this, it might not be immediately obvious that there's an issue here. So you probably want to rewrite cotangent as, let's rewrite this as the limit as x approaches 0. So this will be x, and then this will be cosine of 3x over sine of 3x. So it'll look like this. And now if you look at this, if you plug in 0, so once again, notice you get 0 over 0. And so that's a problem. And then there's no other way I can really simplify this. So ideally, like, you kind of go through like a Rolodex of what are all the things you can do with trig functions. And it'd be great like if you could reduce this in some meaningful way, but we really can't. So we're just gonna have to stick with it as is. Now, when this happens, when you really can't seem to go any farther with it, there's nothing else to simplify, that's usually your first hint that you're going to use the theorem. So I am looking for a way to use this. This is now my new goal. Now, I have kind of a big hint in this, in that I have sine of 3x down here, and I have an x up here. These two things kind of want to be together. I'm going to have to make a manipulation here, but like this is usually one of the things that you're looking for, is a way to get your sine and your x kind of together, and that they're one's on top and one's on bottom. So I want to rearrange this to make this a little more in line with what I'm trying to get to. So I've put those two things together because I know they should go together. And then I'm just going to break out this cosine of 3x separately. Okay, so now I can see by looking at this that this is almost what I want, right? But now it's kind of like the last problem. So the problem is this is 3x, this is just x. So I can do the same manipulation I did before, right? So I can multiply all of this by 3 over 3. So now I can rewrite this so that the top 3 goes here, and then I've got this sine of 3x. So this is what I did with this top 3. I put it over here. This other 3, I'm just going to group it under the cosine of 3x. Like this. Okay, and so now we're in business. So I can go ahead and work with this. This guy now, I'm basically in the right format. The limit also goes, you know, this direction, so I'm basically using this form of the limit. So this part here, this is going to 1. Now, for this other part, I really just have to think about what's happening with the cosine of 3x. So what is cosine of 0? It's 1. So this whole thing then is going to come out to 1 times 1 over 3. So this equals 1/3. And so that's it for this one. So those are my two kind of drawn out examples. So hopefully that was helpful if you were looking for more detail. If you have questions, you can leave me a comment. And I do have lots more examples of varying levels of difficulty and how to use this, because I know this is definitely tough. So don't get too down if you're struggling with this. This is an appropriate topic to struggle with, and you'll probably have to work on it more than once to fully get it. So, you know, if you're feeling a little discouraged, don't worry. It's totally normal. It's totally fine to struggle with this one. It's a tough one.